Today we shall discuss numerical problems on Kennedy's method of channel design and Lacey's method of channel design. So in the earlier classes we have discussed the Kennedy's method of channel design. So there are two cases. The case one is the discharge will be given, the value of velocity coefficient will be given, and the value of critical velocity ratio will be given, and the bed slope of the channel will be given. So that is one step of procedure, that is case one. So the second case, discharge will be given, and the velocity coefficient value will be given, the critical velocity ratio will be given. Instead of the slope, longitudinal bed slope, the B by D ratio will be given. So which is a trial and error method. So most of the time in the examination, either they ask the case one design procedure of Kennedy's method of channel design. So now already we have discussed the step-by-step procedure of Kennedy's method of channel design, and also we have discussed the drawbacks or shortcomings in Kennedy's method of channel design, as well as we have also discussed the Lacey's method of channel design. So in case of Kennedy's method of channel design, the critical velocity and mean velocity is taken as a variable, whereas in Lacey's method of channel design, the hydraulic mean depth is considered as a variable. So now let us go through the numerical problems on Kennedy's method of channel design and the Lacey's method of channel design. So first, Kennedy's method of channel design. So it is case one. So now design an irrigation canal to carry a discharge of 45 cubics and assume the value of rugosity coefficient, that is value of n as 0.0225, and the value of m, that is the critical velocity ratio, is given as 1, and the channel has a bed slope of 0.16 meter per kilometer. So this is the longitudinal bed slope of the channel. So now here the value of discharge is given, q is given, n is given, and the value of m is given, and also the longitudinal bed slope of the canal is given. So it is case one under Kennedy's method of channel design. Now, so according to the first method of channel design, it is case one. First, we have to assume a trial depth of flow. That is, we have to assume a trial depth. That is, assume a trial depth d equal to say 1.8 meters. Now, once you assume a trial depth of d is equal to some value, then we have to calculate the critical velocity. Critical velocity, or it is also called as now the critical velocity equation is 0.55 m into d to the power of 0.64. Now you have assumed the trial depth as 1.8 meters. And you know the value of m. Thereby we get the critical velocity as 0.8 meters per second. Next, we have to
Sir, screen share ಆಗ್ತಿಲ್ಲ. Sir.
Now it's okay. Can you see?
No, sir. No, sir.
Hey, Ganesh. ಏನನ್ನ ಬಂದ್ಬಿಡ್ತು ಇದೇ ಹೋಗ್ಬಿಡುತ್ತೆ ನಾವು ಬಂದ್ಬಿಡ್ತು ಸಾಫ್ಟ್ವೇರ್ ಕರಪ್ಷನ್ ಆಯ್ತು ಅನ್ಸುತ್ತೆ ಏನೇನೋ ಬಂದ್ಬಿಡ್ತಾರೆ
ಸರ್ ಸ್ಕ್ರೀನ್ ಮಾಡಿ ಸರ್
ಡೌನ್ಲೋಡ್ ಆಗಿತ್ತು
ಏನಾಯ್ತು ತೋರಿಸಿಲ್ಲ.
Hello, now it's visible. Screen share.
Yes, sir. Yes, sir.
Okay. So the first problem, Kennedy's method of channel design, we have assumed a trial depth of 1.8 meters. So we can calculate the critical velocity. It works out to be 0.8 meters per second. So this is the second step. First step is we have to assume a trial depth of some value, and second one we have to calculate the critical velocity. And the third step is we have to calculate the area of cross section required. Area of cross section required. So that is given by the continuity equation. Q is equal to A into V. So thereby you can calculate the area of cross section. It works out to be 56.2 meters square. So once you find the area, then next we have to find the bed width of the channel. So the bed width of the channel and also the perimeter of the channel. Now here, the bed width can be got by using this equation. It is the area, correct? Area we know it as BD into plus D square by 2. So thereby you will get the bed width of the channel as 30.3 meters. So this is the fourth step wherein you have to calculate the bed width of the channel. Now, next is we have to calculate the perimeter of the channel. So perimeter of the channel is given by the equation P is equal to B plus D root 5. So thereby you will get the perimeter of the channel as 34.32. Now, we have to find the value of the hydraulic medium. So which is nothing but the area by perimeter. So area already we have calculated. That is here it is actually A. It is A. So here there is a mistake here. It is not V. It is A. So here the area is 56.2 meters and the hydraulic medium will be area by perimeter. So that also to be 1.64 meter. Now, we have to use the Manning's equation to find the mean velocity. So in Kennedy's method of channel design, the critical velocity value and the mean velocity value should be equal to 1. Both should be same. Otherwise, you have to change the assumed depth of water, that is trial depth of water. Now, let us check whether the velocities are same. Now, we have to calculate the mean velocity by using the Manning's equation, V is equal to C root of RS, where C is nothing but it is a constant. It is given by this equation, which is known as the Kutter's equation. So now in the given problem, the longitudinal bed slope, the value of S is given. That is 0.16 per kilometer. That is 0.16 divided by 1000. Correct? So 0.16 divided by 1000. Now we have to calculate this value, constant value from Kutter's equation. So this is the Kutter's equation. Already we have discussed here. So here 23 plus 1 divided by n, 1 divided by n plus whatever the value you get here. So all the values you have to substitute here. That is 0.16 is 0.00155 divided by S. So where S is 0.16 divided by 1000. So 1000 will come on the numerator. Then did that whole divided by 1 plus 23 plus 0.0155 divided by S again into n divided by root R. So R is nothing but the hydraulic medium, whatever you have calculated in step 5. That is 1.64. So when we solve this equation, we'll get the value of C as somewhere around 49. C as 49. Now we have to use this value in this equation. It is the Manning's equation. V mean velocity is equal to whatever the value that C you get from this equation into square root of the hydraulic mean depth 1.64 multiplied by the longitudinal bed slope of the canal. So thereby you'll get the value of the mean velocity as 0.793 meters per second. Now you have to compare the ratio of mean velocity and the critical velocity. So if that value is nearing to 1, then whatever the assumed depth is okay. Otherwise, you have to change this assumed trial depth. And finally, you have to get the mean of the ratio of mean velocity by critical velocity. That value should be nearer to 1. Then hence the assumed depth is satisfactory. So once again, we shall go through this problem. Here you have to design an irrigation canal to carry a discharge of 45 cubics, and the value of velocity coefficient and M is given, and the channel has a bed slope of 0.16 meter per kilometer. First you have to assume a trial depth, then calculate the critical velocity, then calculate the area of cross section. Then you know the area of a standard section is B plus D square by 2. So thereby you will get the value of the bed width of the channel required. Then once you know the bed width, then calculate the perimeter of the canal. So once you get the perimeter, calculate the hydraulic mean depth. Then once you find the hydraulic mean depth, use Manning's equation to find out this constant, that is C, so which is given by the Kutter's equation. So finally, once you find this value of C, then find the mean velocity of flow by using Manning's equation and take the ratio of the mean velocity divided by the critical velocity. If the ratio, that value is very nearing to 1, then whatever the assumed depth is, okay, satisfactory. So these types of problems you may have in the examination under Kennedy's method of channel design. Generally, the case 2 wherein the B by D ratio will be given, so which is a trial and error method in order to find the longitudinal breaststroke of the channel. So the case 1 where Q, N, M and the longitudinal breaststroke of the canal will be given, based on which we have to calculate the area of cross section of the canal required, that is the bed width of the canal and the perimeter of the canal. So here in Kennedy's method of channel design, the critical velocity and mean velocity are taken as the variable. Now next we shall go through the other method of channel design, that is by Lacey method of channel design. Now here a channel section has to be designed for the following data. Here the discharge is given, and here the value of silt factor will be given here. The value of silt factor is directly given as F as 1.00. So otherwise, sometimes the diameter of the silt particle will be given. The diameter of the silt particle will be given. Then in such a case, we have to use that equation, that is F is equal to square root of the diameter of the silt particle. So we have already discussed the step-by-step procedure under Lacey's method of channel design. If the value of F is directly given, then you can omit the second step wherein you have to calculate the silt factor. So here the slide slope of the canal will be given, 1/2:1. It is of no importance. Next, find the longitudinal breaststroke of the canal. So in here, the discharge value will be given to you and the silt factor value will be given. If not, the diameter of the silt particles will be given. Thereby, you can calculate the value of silt factor F. And the slide slope is 1/2:1. It is of no importance in the problem. So this is the step-by-step procedure of the Lacey's method of channel design. So here, the value of F is given as 1. So directly, you can calculate the velocity by using the equation V is equal to QF divided by 140 to the power of 1/6. So here Q is 30 and F is 1. So thereby we get the velocity value as 0.773 meters per second. Now once you find the velocity, then calculate the area of cross-section required, that is Q divided by V. Using the continuity equation, we will get the area in square meter, that is 38.8 square meter. So once you find the area, you can find out the perimeter of the channel by using the equation 4.75 root Q. So here Q is 30. So thereby you'll get the value of perimeter. So once you know the value of perimeter and also the area, you know the value of perimeter and area. So you can find out the depth of the cross section required, depth required, that is depth of flow required, that is given by the equation D is equal to P minus square root of P square minus 6.994 times A. Here, most of the time students forget this. They just write 6.994. So this has to be multiplied by area. So this is the equation to find the value of D. D is equal to P minus P square minus 6.994 times A divided by 3.472. So when you substitute the value of P and A, so you get the value of D as 1.67 meter. So we know the value of A, we know value of P, we know value of D. And the bed width of the channel. The bed width of the channel is given by the equation V is equal to P minus 2.236 times D. So you know the value of P and D. So thereby you will get the value of P as 22.6 meter. Now, in Lacey's method of channel design, the hydraulic mean depth is taken as a variable. Hence, we have to calculate the hydraulic mean depth by using two equations. One is 5/2 V square by F. The other one is R is equal to A by P. So then we have to compare the values of the hydraulic mean depth obtained by first equation and the second one. And if the values are same, then whatever the cross section, it is the area of cross section, the perimeter, the depth of flow, and the bed width, whatever we have calculated, is okay. Now let us cross check whether the hydraulic mean depth obtained by those two equations are near same. Now the first equation to find the hydraulic mean depth R is equal to 5 by 2 V square by F. So V square, it is velocity we have already calculated. V square, correct? So V square by F, the value of F we know 1, and it also will be 1.49 meter. So similarly, the hydraulic mean depth by using the other equation, R is equal to A divided by perimeter, the basic equation. So there it also same value, it is 1.49 meter. So hence the design is okay because both the values of hydraulic mean depth are same. Whereas in the Kennedy's method of channel design, we have compared the mean velocity and the critical velocity. Whereas in the case of Lacey's method of channel design, we are going to compare the hydraulic mean depth by solving those two equations. That is R is equal to 5 by 2 V square by F, and R is equal to d by d plus V square by 2 divided by the value of the perimeter. Now finally, you have to find the longitudinal bed slope of the channel. So this longitudinal bed slope of the channel is given by the equation S is equal to F to the power of 5 by 3 divided by 3340 into Q to the power of 1 by 6. So you know the value of F and we know the value of discharge. So thereby we will get the longitudinal bed slope of the channel as 1 by 5900. That is, for every 5900 meter, you have 1 meter flow. So now hence the channel has a bed width of 22.6 and a depth of 1.6 meter, and the longitudinal bed slope as 1 by 5900. So this is the design procedure for Lacey's method of channel design and the Kennedy's method of channel design. So in the examination, either you may have a numerical problem on Kennedy's method of channel design. So in the theory part, they may ask the design procedure of Lacey's method of channel design, or otherwise they may ask the design procedure of Kennedy's method of channel design, and you will have a numerical problem on the Lacey's method of channel design. So I have only I require another 3-4 classes to complete the 5th module. Anyway, after the second test, we shall join back. So the portions for the second test is module 2 and module 3 and module 4. So module 5 is not included in the second internals. So I think your second internal starts from tomorrow. So these are the problems on Kennedy's method of channel design. So you can go through the also, you can solve those problems, and the procedure remains same. The design procedure for Kennedy's method and Lacey's method of channel design. So please mark your attendance in the chat box. I will be ending the session. So after the second internals, we shall start a new chapter, that is reservoir planning. So that completes the entire syllabus, module 5. So please mark your attendance in the chat box. Do you have any clarification, anyone? Anyone has any clarification or doubt? Nitya P.
Yes, sir.
Any doubts? Any clarification? Everything is okay?
Yes, sir.
Anyway, I will share the notes in the WhatsApp group, these problems. And this is not included in your second intervals. Okay. So I will be ending the session. So we shall meet after the second intervals. Till then, have a nice day. Stay safe. Good luck.